Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 8-2 Part 1 homework solutions on geometric series. For this problem, we want to find the 10th term of a geometric sequence that starts with -2, and the next term is -8. So let me write my general nth term formula. A sub n equals a1 times r to the n minus 1. And then for a1, we've got -2. For r, we just divide one term by the term before it to figure out what we have to multiply by each time. So -8 divided by -2 gives us a common ratio of 4. So plugging it all in, we've got -2 times 4 to the 10 minus 1, which I will now do on the calculator. So plugging all that in, I've got -2 times 4 to the 10 minus 1, giving me -524,288. On this one, we're trying to find the 37th term of a geometric sequence that begins with 125 and this number, 15,625. So to start that, we're going to start with our formula for the nth term of a geometric sequence, a1 times r to the n minus 1. So a1 in this case is the 125. That's our starting number. For the common ratio, we need to do 15,625 over 125 to see what I have to multiply by each time. So that's going to end up being, let me use the calculator for this. Let's see here. That's going to come out to, 125. Well, how about that? Isn't that fun? All right, so we've got 125 for the a1 value times 125 for the r value raised to the power of 37 minus 1, because 37's our nth term here. And now I'll just do that on the calculator. So there we go. And you probably noticed that you could have just done 125 to the 37th. Either way, you should get 3.852 times 10 to the 77th power. On this problem, we're trying to find the 22nd term of a geometric sequence with the first two terms of 12 and -48. So for this, we'll use our nth term formula. That's a1 times r to the n minus 1. So that's going to be 12 times, well, let's see, what's our common ratio? That's going to be -48 over 12, which is going to be -4. So that's our common ratio we have to multiply by to get the next term. So we've got 12 times -4 to the 22 for n minus 1. And now we just have to carefully plug that in the calculator. So plugging this in the calculator, you'll notice I have my -4 inside of parentheses. That's not going to matter on this one because we have an odd exponent when all is said and done, but for even exponents, that's going to make a difference. So pressing enter, we end up with -5.278 times 10 to the 13th power. For this problem, we want to know the 9th term of a geometric sequence with the first two terms of 64 and 32. So we're going to use our nth term formula, a1 times r to the n minus 1. We know a1 is 64. The common ratio, that's what I have to multiply 64 by to get 32. So that's just going to be the second term over the first term, 32 over 64, gives us that common multiplier, that common ratio of 1/2. So plugging that in with my first term now, I have 64 times the r value 1/2 raised to the power of 9, because we want the 9th term, minus 1. And you could use a calculator for this. Now, I happen to know that, let's see, 1/2 to the 8th, that's really 1 over 256, and 64 over that is 1/4. But you could use a calculator to figure it all out. 0.25 also works. For this problem, we want the sum of a geometric series that has 9 terms, begins with 2, and has a common ratio of 4. So for this, we can actually go straight to the sum formula. That's a1 times 1 minus r to the n over 1 minus r. So we have 2 times 1 minus 4 to the 9. They gave us that one too. All over 1 minus 4. And now we just have to plug it in the calculator. There we go. That's going to give us a grand total of 174,762. For this problem, we're trying to find the sum of this geometric series. So I'm going to start with my sum formula. We've got a1 times 1 minus r to the n over 1 minus r. So we have to figure out a1, r, and n. A1 is just your first term, which is 1. And then for the common ratio, it looks like we're multiplying by 5 each time, so 5 is our R value. And then for n, how many terms do we have here? The last one is 5 to the 32nd power. But the first one here, this 1, you could really think of this as being like 5 to the 0. So there are 33 numbers, including 0 and 32, to go from 0 to 32. So this is going to then be 1 times 1 minus 5 to the 33 all over 1 minus 5. And now for the calculator, where plugging all that in is going to give us 2.910 times 10 to the 22nd. On this problem, we're trying to find the sum of this geometric series. So let me start immediately by writing my partial sum formula. That's a1 times 1 minus r to the n over 1 minus r. We have an a1 value of 1. That's our first term. The common ratio, r, that's going to be any of these terms divided by the term before it. Probably the easiest one to do is just 12 over 1, so 12. And then for n, well, it looks like, what's our n value? How many terms are there in this series? You could think of this 1 as really being kind of like 12 to the 0. So if you have 12 to the 43rd as your last term, that means there's actually 44 terms on this one. So when all is said and done then, we have 1 times 1 minus 12 to the 44th all over 1 minus 12. And now for the calculator. So there we go. I highly recommend you use your fancy fraction alpha y equals form when you do this on the calculator. And that comes out to about 2.771 times 10 to the 46th power. For this one, we're trying to find the sum of a geometric series that has 12 terms, first term of 8, and a common ratio of -2. So they've actually given us everything we need to go ahead and use our formula here right away. A1 times 1 minus r to the n over 1 minus r. So this will then be 8 times 1 minus, now I'm going to put this -2 in a parentheses to the 12th power, and then I'm going to have 1 plus 2 because I'm subtracting a negative there. Let me go ahead now and put that in the calculator. So entering this in the calculator, and I'm also using my alpha y equals fancy fraction form to not get messed up on PEMDAS, this should come out to -10,920. If you got something different, maybe you forgot to put this -2 in a parentheses, it will make a difference on this one because of PEMDAS.